Welcome to everything you need to know about UML. That's the Unified Modeling Language. My name is Will Goodwin. I'll be your instructor for this course. What we're going to do in this course, first off, is probably no big surprise, define just what exactly is the Unified Modeling Language, what goes often by its acronym, UML. We'll define what it is and why you should care. What will it do for you? And provide you a little history lesson on just exactly how did we get here? Where did the UML come from? And in particular, how do we use it? We'll provide you several different ways, several different techniques for using UML for different purposes. And the way you use it is create diagrams. We will show you all 13 diagrams defined in the official UML standard and give you a chance to create an example of each one of them. Additionally, we're going to focus on reading and interpreting those diagrams and the elements that appear on them. Also, how you can create them and how you will know which diagram to use for a particular problem. And the UML standard is incredibly extensive. We're not even going to pretend to cover all of it. What we are going to do is identify and explore the features of the UML that give you the biggest bang for your buck, the most relevant features, the most useful ones, that will give you the ability to create diagrams that communicate your software design effectively to all of the members on the development team, including analysts, designers, implementers, testers, end users, stakeholders, etc. What's the prerequisite? Well, if you have familiarity with object-oriented programming languages, if you know what an object is and what a class is, then you're ready to go, because the Unified Modeling Language was designed to support exactly that, object-oriented programming languages. What are we going to do? Well, to begin with, we start with the big picture. The overview of UML, the history of it, where did we come from, who was involved in developing it. And then we look at how the UML fits into a development process, because the Unified Modeling Language does not itself define a development process, but we will suggest some types of processes that are a very good fit with the UML. One of the first things you'll need to do for a new development project is identify requirements. What is the system supposed to do? That's where use cases come in. They help you capture and document system requirements from the user's point of view. We'll give you some tips on how to do this effectively using those use cases. And then, once we have some requirements in hand, we will start to move toward more of an implementation viewpoint with the class diagram, where we'll define the types of objects that will make up our system. And explore that a little bit further ideas with the class diagram for modeling our problem domain, that is the area that is associated with a system that we're building, and adding in more details, probably things that you would do during the design phase of development. Now, the class diagram is great for a static viewpoint of what are the objects, what kind of objects will be in our system. But if you want to describe how those objects work together, you need a behavioral diagram, like an interaction diagram. We'll take a look at two types of interaction diagrams, or actually 3 or 4 by the time we're done, that will give you the behavioral point of view. State machine diagrams focus on one particular kind of object and provide you a way of describing its life cycle. Whereas package diagrams give you means for organizing a complex project hierarchically using packages. And activity diagrams are kind of the jack-of-all-trade diagrams. They fit into everything from requirements capture, augmenting use cases, all the way down to they can be used for providing the details of a very complex algorithm that might be implemented in a method in a class. The software architecture of your application can be described in terms of software components on the component diagram, whereas the physical architecture of your system can be described on a deployment diagram, which will give you the opportunity to describe the computers, the hardware that make up the system, and how those components can be deployed on the hardware. By this point, we've covered 9 of the 13 diagrams. We still have 4 remaining. Those fit into the diagrams of a lesser God topic. They are less commonly used, more specifically purposed. But we will discover them, we'll talk about them, we'll give you the opportunity to try them out. And then we'll wrap up with a technique for describing how to extend the standard definitions that the Unified Modeling Language gives you, and give you a collection of practices, pretty good practices, tips, and hints on how to do your UML modeling effectively. If you have any questions, then feel free to use the question comment box. That's what it's there for. The hands-on exercises in the course can be, they are all based on a case study, and they can be downloaded. The case study can be downloaded from the paperclip link. So let's go ahead and get started.